you can all sit so we can kick it off. So, an exciting topic on LLMs. Good. Yeah, so hopefully everybody enjoyed their break. Really excited to see everyone still here. I mean, I think we've got this presentation, which is two excellent presentations, and then 4:45 we'll have drinks and dinner across the street, not outside. So it's not going to be outside. It's inside, very far, almost like a bunker. So old Wall Street place. So we'll be away from the smog, you know. So without further ado, really great to have Iro present on basically generative AI and some cost and risk considerations. Iro's the head of investment data science at T. Rowe Price, and it's a very timely topic. So Iro, over to you. Thank you.
Thank you. So let me start by saying that I may be sounding provocative every now and then, but just disclaimer, I mostly have questions rather than answers. So even if I sound like I'm coming up with an answer, we all know that this is such a fast evolving field. So that would be at least immature to claim, oh, that's it. Okay? And with that, we're going to experiment. Okay, it works. Okay, so I guess this audience does not need lots of context, and you already had enough. So ChatGPT took the world by storm, kind of forced the hand of others, right, to release their LLMs, and now we have a lot of those. It definitely caused a lot of enthusiasm everywhere, finance, the world. And one way to look at it is the fact that it reached its 1 million user milestone in 5 days. So these are engineering marvels for sure, but with the opportunity of potentially leveraging these comes the responsibility to ensure that we do that in a safe way. And I guess I don't see any other way better to enforce that other than educating ourselves constantly and the businesses so that we make sure the usage is proper. And from all services or industries, sorry, I would argue that financial services are most definitely need that. We are a highly regulated industry. All right, so in this talk, I may bore you a little bit, but I'll be brief, reminding you how ChatGPT was built. And mostly, I will discuss physics to see and get some understanding on what generative AI may mean. And also, we'll discuss a little bit how large is large, because after skimming through the usual risks, usual but still important, mostly I will use our conversation on generative AI and the definition of large to just, give us some food for thought of these big models, these complex models. There has to be cost and risk coming with that I'm sure we all agree. And last but not least, despite, of course, challenges, I will discuss how I think about language tasks as well as the role that large language models can play. So ChatGPT, its definition comes with a bunch of buzzwords: conversational AI, built on top of generative, pre-trained, transformer, large language model. How many people in here would identify as business people rather than data scientists? Okay, we have to respect the minority. The rest of you that data science and AI and all these terms, bear with me. I think it's still good to skim through those and help our business partners understand a little bit more. So apologies to the experts. So ChatGPT. So what does GPT stand for? Generative Pre-trained Transformer. The generative refers to the fact that you have a tool that creates novel content. We can get to that shortly. The pre-trained refers to the fact that, in principle, you can have a model trained for either a specific task or in a task-agnostic way. And these very large, very expensive to build models come pre-trained, so they know language. But then on top of that, you may want to fine-tune it or not, as we've discussed previously. The transformer large language model term We will discuss large language shortly, but transformer itself, think about it as an architecture or something anyway, a mechanism that basically offers you the possibility of relating words and concepts in a sentence so that things are not just in a bag, all of it, without knowing what came before. And of course, it's deep learning, neural nets, etc. And last but not least, the chat in ChatGPT refers to the fact that it was trained for conversational AI. So this is an example of fine-tuning or being tuned for a specific task. So we've already discussed generative AI. You've probably heard this definition. I have to admit, I never really understood it. Novel content, okay. So I would say that before 2020, I don't know about you, but I had never seen generative AI like as a phrase being used. I had, of course, I know generative models versus discriminative models, right? So one tries to learn the joint probability, understand the data and how it's embedded in space, and then you have discriminative, which is the conditional probability. So discriminative would be what is the probability of, I don't know, something being class A given all the features for the people that are not experts. And of course, we had seen it in the context of generative adversarial networks. You have a generator, produces anything the generator wants, and then you have a discriminator that picks and gives feedback effectively whether this is okay or not to eventually create something really powerful. I'm not making the statement by no means that generative AI does not relate to these things. By all means, it does. That said, I was curious, and I was like, okay, if you look online and you look specifically for the phrase generative AI, how back can you find something? I don't know if it was first proposed by this gentleman, van der Zondt, but that's what I found, at the University of Groningen. So he wrote a thesis called Generative AI, a new cybernetics analysis. Bear with me, these things sound abstract, but I promise you, hopefully, I'll make them less abstract. So a main tenet, if you wish, or a part of the definition that the individual is giving to his proposed generative artificial intelligence is that the machine is provided with mechanisms to actively explore possibilities. What does this even mean? I borrowed this picture. Whoops, no, that's not what I wanted to do. Now you've seen all my secrets. So, as I was saying, I borrowed a figure that we're going to go through now from the individual's thesis. On the left-hand side, I guess it is left-hand side for you too. On the left-hand side, you see what is more the classical point of view. You have a loss function, you're trying to find, its minimum, hopefully it's global and not local, and you're done, right? So what the idea here with generative AI is, that's not the ultimate objective. The idea is not to find, sit, and stay. Rather, you should be looking at it as a dynamic system, and basically the right-hand side allows for bifurcations away from the optimum or the optimal solution. You'll see when we talk large language, we will connect it with the fact that it's never the higher probability word that is being returned, right? So that's kind of the equivalent of what I mean, that you're not always picking the optimal solution. When it comes to cybernetics, probably you're all familiar with Kubernetes. It's the same word, basically. It comes from Greek. I happen to be Greek, which means governor, captain, orchestrator. And cybernetics is just a field, just to connect it to the thesis and generative AI, is a field that looks into control processes. So if you have a temperature moderator at home, right, this is a cybernetic system. Why? Because it has a monitor. This monitor calculates the differential between the temperature in the room and the temperature you want it to be at. It sends this differential to the controller, and then the controller initiates a process with a circuit, so the AC goes on, etc. So I know these sound esoteric, but it's amazing how all these things connect. And I guess you can see at the bottom of the page that the AI or generative AI, through all this kind of background, is expected to be unpredictable by design. That's where creativity comes from. And this is not unheard of. And who knows, maybe that is the way for real intelligence, whatever that means. And I'm not even sure we want it. I would be scared of real intelligence. But I'll just give you here an example that there is a whole area in science, generative science, that basically is focusing on studying complex systems. And the idea, the important thing is that there is the phenomenon of emergence. Emergence are behaviors that, if you were to look at the individual components of a system, you couldn't have anticipated, right? So on the right-hand side, I show you a silly example. Let's say that you have a computer and you prepare, a program. And in this program, you allow for neutrons, you allow for protons, you account for the forces. Remember back in school, so protons are repelling each other because of electrostatic force. All other nucleons, neutrons, and protons attract each other because of the strong force. And then you play around with numbers of these things. And then you realize that, wow, you reach a certain number that this thing is going to split naturally, and it's going to release energy. You never put nuclear fission in there. You never put, that, oh, there is, nuclear energy. So this would be an example of when you're looking at a neutron and a proton in isolation, okay, you cannot anticipate all these phenomena. So, and that's again an example of emergence. And it is conceivable that the macro level in our world actually may have emanated as the result of emergence of interactions. If you haven't guessed it yet, I'm a physicist. Used to be anyways. So, and actually there are discussions online and in literature that maybe this emergence is responsible for self-organization, biodiversity, maybe even life. So self-organization, I take it you understand the other things, is the fact that in nature often you have systems spontaneously organizing themselves. That would be like animal herding. That would be for more physics-oriented people. In chaotic systems, they are chaotic, but there are islands of predictive, initial conditions that you can predict very well the future or the evolution, even though it's a chaotic system. Anyway, long story short, we are out of, that's what the short story is. Did I do something? See, I was talking about cybernetics and so yeah. So while we're waiting for technology to not let us down once again, even though it just did, let me just say that basically, again, the message from all that is that there may be something interesting that we are kind of touching, maybe even scary. And also that the most important thing is that generative AI, by design, is meant to be unpredictable. And maybe through this unpredictability, one day, very far in the future, we shouldn't get scared at all. It's very far if it ever is going to happen. Could be how you end up in life or in real intelligence. Now, while we're waiting for the technology to come back, I will also say that some of you, there is actually literature that talks about emergence, even though it's a little bit differently defined. So basically, they are showing that for certain tasks, if you plot performance as a function of number of parameters of the model, so now we're not talking physics, we're talking LLMs, right? You will see that there is a smooth improvement, and then as soon as you exceed a certain number of parameters, a certain size, it spikes up. So it's like a step function. And they have referred to it, I mean, I haven't spoken to the authors, but I'd love to. They refer to it as emergence, like something unanticipated, like the normal behavior would have been, okay, you go up, go up, go up. What happens at this threshold value that it shoots up? All right.
Emergence, we were just talking about.
Thank you. Okay. I managed to entertain, right? While the
Get the right number of parameters, you got a presentation.
Thank you. Well, I did get that. I'm not sure about the rest. Okay. I should have had my laptop open. At least I would remember what comes next. Okay. All right. So, as advertised, we discussed a little bit generative, but like kind of from a different lens, and also language models. Again, for our partners from business, a language model in its simplest form is a model that looks into lots of text and learns how to predict what the next word will be in a sentence. Again, bear with me, simplest form. Generative language model, right? You can see the second example that there is a probabilistic approach that we all know. So when you say the students open there, it can be books, laptops, exams, minds. And even though in a classical approach, the solution would be books again and again, the generative element allows for, every now and then to not use books. And that's how you have basically potential emergence, potential, new content that we're discussing. So, and that's the connection with generative. Now, as I promised, I also will touch a little bit upon large because the conversation we're going to have around costs and risks are not going to be, as I said, the usual, like ethical, or which are all very important, but mostly from a data scientist point of view, the things that you start wondering about. So large language model means a very large number of model parameters. GPT-3, who is ChatGPT's predecessor, had 175 billion parameters. Even though not a one-to-one correspondence, given that we're talking about neural nets, it's still instructional to compare with the number of neurons in the human brain, which is 86, less than half. Again, just instructional, just put magnitudes next to each other to grasp the magnitude of what we're talking about. GPT axioms. What did you say? Like, why did I?
No, shouldn't you compare the connection, not the neurons?
Oh, yeah. That's what I'm saying. That, I mean, it's instructive, right? Just to put numbers. You're correct. It's by no means a one-to-one, or, yeah, it's synapses, it's neurons, absolutely. So probably if you have 86 billion neurons, oh my God, you have 86 times. So it's factorial, right? If you do pair. Yeah, okay. Okay, that makes me feel better when I'm going to say that GPT-4 is rumored to have more parameters. So they say 1 trillion, I don't know. Some people say 100. I don't know if they've published anything that I missed because things are moving too fast. But you're correct on that. So again, these are just to put kind of things in some kind of numerical context. The training corpus, again, I'm using GPT-3 numbers because these are the ones that were published, even though the 8 million, I think, was referring to 3.5, to GPT 3.5. But anyway, a ton of context, right? A ton of tokens, a ton of data for almost 100 different languages. And the number of floating point operations to train GPT-3 is of the same order of magnitude to the estimated total number of stars in the universe. So we're talking about something astronomically large. And at this point, two things. Let's pretend we didn't hear or we don't remember anything from what I said. So generative LLMs are expected to exhibit unpredictable behavior by design, have an enormous size, number of parameters, complexity. All these, I'm treating them as the same thing. So some cost and risk considerations. That should be, the usual cost, financial cost, of course, it's OpenAI that has assumed, but eventually if you're going to use it, you'll have to pay for it. Energy consumption, of course. Carbon dioxide production. Actually, for GPT-3, it was said that they probably created the equivalent of 5 to 7 cars worth of carbon dioxide, cars throughout their lifetime. But they did argue that and did say, and that's true, that the infrastructure was not the best, so things are not going to be that bad. When it comes to risk, you can talk legal, you can talk societal, you can talk reputational. The reputational refers to the fact that, for example, if you're going to use ChatGPT, supposedly, if you believe Times Magazine, they were discussing that they used in Kenya people in unfavorable conditions to help them clean the training corpus from so-called harmful materials. Again, I have nothing against OpenAI. I'm working there, right? I mean, like that's my job. I want to advertise, so we're gonna get there, to the good things. So, as I said, next I want to discuss a little bit costs and risks from the data scientist point of view, i.e., something that you would think about if you're a data scientist that also can have consequences on usage by the business. So, model complexity as cost. I know all of you recognize what I'm trying to say. A model's performance should not be looked in isolation. It should be looked at in tandem, right, with what you're paying. And often in models, we are on the right-hand side, you can see the Akaike criterion, right? So this is a way to say, okay, performance may be increasing, but do I care only about performance? Shouldn't I care more in return per unit cost, right? So that's what I'm trying to say. So these are very costly models, very big. So are they do as well as you would expect when something is so big? As I said, I'm just being provocative. The answer is not no, they don't, right? I'm just trying to stimulate some thinking around. So given how complex it is it good enough? I don't know. On the left-hand side, I have an example of how ChatGPT feels obliged to satisfy. So if you're going to ask 5-year states starting with the W or 7, in both cases, as we all know, you're going to get something. On the right-hand side, you can see the inability to distinguish, to understand numbers versus steel and feather. So again, we all know about hallucinations. We know that it's making things up. And again, the question in the air, without an answer from me, is that good enough given how complex the model is? Just a question. So let's move forward a little bit. So the number of parameters, or rather, what are parameters? Parameters are information compression mechanisms. So you have 1,000 data points, and you want to fit a line so that you only have 2, and you can go anywhere, you can put it in your pocket. It's easy to carry, right? Because you encoded information from the data set, so you don't need all 1,000 points with you, right? So every time we build a model, that's what we're actually doing. We are compressing the information, and depending on how many parameters we have, which is the capacity of the model to hold information, we hold the relevant amount of information. So we have already gone through that, just as a reminder, and I know I need to put a reference citation, so it's not missed on me that I'm using a table from the GPT-3 paper. I'll fix that. But this is just a reminder of things we discussed earlier, the 8 million pages, etc. So shall I press again? I will. Okay, so where I'm headed at is the statement I will make. I'm not gonna, okay, so I was about to, not statement, to ask the question, when you have that many parameters, right, it means that you have the capacity, and you do hold a ton of information, right? So in data science, we don't like that. We call it overfitting. But at the same time, if you could overfit everything that's out there, you know everything. So here's the question. Are LLMs really intelligent? Or are they knowledge imitating intelligence, which frankly is also known as memorization? And why am I asking that? Because they're so big that aren't they enormous knowledge databases? Do they really need to think? They know, they don't need to think. And you may say, so what, Iro? We have some real effects happening and meanwhile. Okay, so why does this matter, right? I'll tell you why. Not because they're not useful, they're going to be changing our culture, changing everything about the way we do things. But in our company, at least, or in any company I would be, my main concern is over reliance. I know it might be disappointing, but really, what I think is the biggest concern for me is not helping people understand what they do, what they can do, what they cannot do. So my concern is that, we're not going to develop. There it is. No, that's the wrong page, though. Okay, I'll get there. So I think that understanding the distinction between intelligence and knowledge, imitating intelligence, is really important for the purposes of risk management. So over-reliance, as we've all said, you don't send something out just because ChatGPT wrote something. Human in the loop always. And then there is the other risk that if we believe too much of these things, then the public will think too much of these things. And this may create like really over-sensationalized things in the press. And as a result, for all we know, everything will be shut down. So there are bad things of over-reliance and misconception across the board. So before we go into, okay, so what do we do with that and how do we use it in finance? Of course, I shouldn't, not mention interpretability, explainability. Again, in finance, people want to know how you got what you got. So the more complicated a model, the less the chance that you can tell a story. And last but not least, to come full circle, again, generative basically is unpredictable by design. So emergence may happen, may have happened, may never happen. It's just a hypothesis. But from all fields that you don't want this to happen, that would be finance. In finance, you don't want creative answers every time you ask a question to get a different answer. Okay, so what does that mean? It does not mean, as there were so many of you that discussed exactly how it is that we can actually deliver value. So I will tell you how I think when I think of, be it an investment bank or an asset manager that I'm at. So in my mind, when I'm thinking of our user, I think of the 3 C's of content. That's how I call it. So the first is consumption, right? So people want to fastly have access to the main pieces of information from a document. The second is characterization. People want to know whether there is a tone, whether it's a positive, whether it is different than the previous year's 10K, etc. And the third is creation. So maybe help with emails or whatever. I would argue, and I don't think I have to try hard to convince you, that content creation is what clearly LLMs are really clearly established as good at. And here are examples. Again, I will share the deck, but in the interest of time, basically I have examples around describe what stock and bonds are doing under different market conditions, be it interest rates, etc. I think I have another at the bottom left for marketing purposes. So the idea is that, okay, we're about to launch a new strategy combining 4 of our already existing strategies, and we want to target pension funds. And you can see it's extremely creative. The right-hand side is a poem for our analysts that I shared recently. So we've seen that already. So, okay, not always reliable, but again, still creative. So I'm not going to go through this. This is exactly the same page, just to remind us that creative they can be, reliable, not really. Then let's say we go into content consumption, right? So here is an interesting flaw. Let's say that you have a 10K and you ask top 3 risk factors, and then you ask top 5 risk factors. Naturally, I would argue, you would expect that factor 1, 2, 3 in the top 5 list will be identical to 1, 2, 3 in the top 3 list. Or there's no concept of top then, right, of ranking. So you can see here that the third one is and it's not. Actually, it's not the same. So you would expect, again, the 5 risks to be just an augmented version of the 3. On the right-hand side, a silly example of summarization where I identify, for example, that there is some overlap. So you have already limited real estate to write a summary, and you waste it by having overlapping messages, like kind of repetitive. All that happens because there's no semantic understanding of the language, as we know. And when it comes to summarization, I'm very sensitive. And what I mean by that is that what you're guaranteed to get is a shorter text, not necessarily the correct text. So I was told that I'm running out of time. Did you take into account the tech challenges? Okay, so the next page is to discuss that all this good stuff that you guys talked about, so we can have, it went all the way to the last one. So all the good stuff, prompt engineering, fine-tuning, in-context learning, you name it, maturity that we will all have to wait, when things really mature and reach the right level. And then I'm sharing what I think is the most obvious use, given where LLMs are. And in my book, it's user experience. Is the way to use, if you think about what got everybody so engaged with ChatGPT, they would go and they would be talking to something. So a vision that I have for the first use case is having a portal, right? Under the hood, you may have, all possible IP or data of your company, and you use the LLM on top, not necessarily to do the NLP work per se. It's not going to be necessarily the one you do sentiment with, but rather to create this more engaging user experience. But again, clearly, as everybody else, we're doing all the other stuff that you discussed and mentioned. Thank you.